Today we're going to look at 6.6, the law of cosines. So this is another rule. It's going to be useful for triangles where the law of sines actually cannot be used. So what I'm going to start with here is going to be the derivation of this rule. So this part's a little more interesting. So see if you can follow the steps. So I'm going to start out looking at this right triangle here on the left side. So let's see, if I look at that right triangle, let's see if I call, let me see if I can find, say, the cosine of the angle A. So that would be, let's see, the adjacent over the hypotenuse. So x over b. Whereas, let's see, the sine of the angle A, what would that be? That would be opposite over hypotenuse. So that would be y over b. So let's see, I guess that would imply then that x is b cosine A and y is b sine A. All right, so let me clean this up a little bit. Okay, so then I'm going to look at the right triangle on the right side here. Okay, so I'd like to fill in this length. Let me see if I can label that. So this whole length here is C. Let's see. I found this value x, didn't I? Wasn't that b cosine A? So that's the distance from here to here, right? And then I actually found this y as well, didn't I? So let me see if I can fill that in. Wasn't that b sine A? Okay, clean this up again. All right, so then again, looking at this triangle, wouldn't this length be C minus B cosine A? In other words, that length would have to be this entire distance here minus this one here, right? So what I'm going to do now is I'm going to use the Pythagorean theorem on this right triangle. So let's see. That would look like b sine A squared plus c minus b cosine A quantity squared equals a squared. So b squared sine squared A. This one's a FOIL. So if you need to, you can do this off to the side. So what is that? That's c squared. It'll be minus a bc minus another bc minus 2bc cosine A. And then plus a b squared cosine squared A. Okay. That's the scratch work. Okay, so let's see, I want to group this with this. So I've got a b squared sine squared A. I've got a b squared cosine squared A. I've got a c squared minus a 2bc cosine A. So actually, from these first two terms, I can factor out the b squared as a GCF. And then actually, look what I'm left with. So this is my special identity, right? That is 1. So actually, don't I just have b squared times 1 plus c squared minus 2bc cosine A is a squared. So actually what I found here, this is called the law of cosines. So I can write out a few variations. So the one we found is a squared is b squared plus c squared minus 2bc cosine A. So I mean, I can relabel and I can write out this same formula for b squared or c squared. So the way I think of this is kind of a pattern. So look what I have here. I have the two other sides. So if here I'm using b squared, then this is going to be a squared plus c squared. And then I have minus 2. And then look what I have here. See how these guys match these guys? So this one's going to be AC. And then one more time. So look at this guy matches that guy. So this one's going to be B. Okay, so next one. So look, this is C squared. So that means I'm going to have the others A squared and B squared minus 2. These guys match these guys. So these guys match these guys. So this is going to be AB cosine. And then again, this one matches this one. So this is C, the angle C. So there's my derivation of the law of cosines. So let me look at a couple of examples. So I'm just drawing a generic triangle here. I'm going to make that look kind of nice. And so let's see, let's call this in angles A, B, and C. And then with this one, the information that I know all three sides. So the thing is, if you were going to try to set up the law of sines, it would look like this. But actually, in all of those variations, you're going to have an unknown since you don't know any of the angles. So that tells me that this time I'm going to need something different. So I'm going to need the law of cosines. So I'm just going to pick, one of these angles. Say I pick the angle A. And then in that case, I'm going to use this variation of the law of cosines. So let's see, it's going to look like 5 squared. And then I put my other two sides. So 8 squared plus 10 squared minus 2. And then I have to fill in these bubbles. So remember, these numbers here match these numbers here. So this is just an 8 and a 10. And then this angle corresponds with this side. So in that case, I would be interested in the angle A. So then I just have to do the arithmetic, and I'm solving for this quantity. So let's see, that's 25. Is that 164? 16 times 10, 160. Now I cannot combine these, right? Because the 160 is attached to the cosine, the 164 is not. So instead, I'm going to subtract the 164. So what is that? Negative 139. And then divide. So cosine of A is 139 over 160. So A would be the inverse cosine of 139 over 160. So there's a nice test answer or exact answer. So I won't bother using a calculator. Let me just go ahead now and find the angle B using that pair. So I would be using that variation of the law of cosines, but look, I mean, if I'm setting this up for B, let's see, the side B is 8, so it's 8 squared. And then I have this template, right? This is my law of cosines template. Okay, so I'm going to put the other two sides. So if I use the 8, then I have the 5 and the 10. The 5 and the 10 match here. This is the side B, so this would be the angle B. And then I just solve for this quantity algebraically. So 64, 125, 100, subtract the 125. Divide by negative 100, so that's 0.61. So B is inverse cosine 0.61. Okay, so now I found, let's see what I found. I found the angle A, this one, the angle B, this one. So all that's left to solve the triangle is to find that angle C. So here's the simplest way to find the angle C. Wouldn't the angle C just be 180 degrees minus the other two angles? Because we know all the angles in this triangle must add up to 180 degrees. So then I found all of my necessary information, and therefore I have solved the triangle. Now I was just going to point out here as kind of a side note, I think the law of cosines is a little easier than the law of sines, because actually in this case, is it possible that I would have two triangles? Because look at something like this, for example. When I find something like, actually let's even look at this line. You see how when I find something like cosine B equals 0.61, think about the circle. So there are two places where cosine could be 0.61, but with cosine, one of the angles is going to be in the top half, the other is going to be in the bottom half. So the thing is, this angle down here, since it's in the bottom half of the circle, this guy always exceeds 180 degrees. So actually with the law of cosines, I don't even have to worry about the case of two triangles, because the difference was, you see how when I was working with something like this, sine of B is a half, say, the law of sines problems, I had two places, and actually both of these places were in the top half of the circle. So both angles in that case were less than 180. So in that case, remember I had to consider the possibility of having two triangles. Okay, but not with the law of cosines. So this is kind of a side note. Side note. Okay. So should I go back then and do, say, one more example for solving the triangle? Okay, I'm starting out with just a generic triangle setup here. And then let me see what information is given. This time, I know the angle A is 60 degrees. I know the side B is 5, the side C is 6. So actually, if you try to set up the law of sines, here's what would happen. So actually, you see here, no matter how I set this up, I'm going to have more than one unknown. So actually, in that case, I would be stuck. So instead, I'm going to go again with the law of cosines. So I'm going to have to use the given information. So you see how the angle that I'm given is 60 degrees? So let's see if I can set that up. So with the law of cosines, here's my template. So I'm interested in a squared. And then it looks like this, right? Okay, so let me fill in the other two sides. So I've got 5 and 6, those match here. And then the angle A is the 60 degrees. Clean this up a little. This is the side 5. Okay. So then let's see. So simplify. 25, 36, 60. Let's see. Cosine of 60 degrees, a half. That right? So there's my side A, root of 31. Okay, so then let's see. I guess I'll just need to find one more angle. So I don't know, say I go for the angle B. See if it'll let me erase that. No, I guess not. Let's erase it. Scratch work. Okay, so then I'm going to set up the law of cosines with that angle B. So that guy found. So my B is 5, my side B, and then here's my template. This is always the same. Okay, so I put my other two sides. So I guess that would be 6 and root 31. Let's go here as well. And then the angle B. So 25, 36, 31, 12 roots of 31. So, be 67. So let's see, what is that 42? Negative 42. And then I'm going to have to divide by that coefficient. Let me see if I can reduce that. So let's just see if we can finish simplifying this. Let me see, I can divide at least by 2. Be 21 over 6 root 31. Oh, I guess I can divide again. So let me see. By 3. 7 over 6 root 31. So if you want to, you can rationalize. I mean, the thing is that, well, ultimately my goal here is really to find b, right? So to actually find b, I have to take the inverse cosine of this quantity anyway. So because I'm like doing something else to this quantity anyway, and like this guy itself is not actually the answer, I probably wouldn't bother rationalizing the denominator. But if you want to, you can. I'm going to leave my answer like that. So then let me look back at my triangle and see what I have then. Okay, so let's see. I have the side A. So I've got 1, 2, 3 sides. I have the angle A and the angle B. So the only thing I'm missing then is the angle C. So again, I think the simplest way to get the angle C is going to be to just subtract. So the angle C is 180 minus 60 degrees minus the B that we found here, right? So let me go down here. So I guess my C would be 120 degrees minus the inverse cosine of 7 over 6 root of 31. And I would leave it there. So let's see, I've got that guy, I've got that guy, A, and then I think we've got everything. That's that one. So we've solved the triangle.